Hello friends, today in this session we will discuss past and future of road construction, particularly in Indian context. The invention of wheel in early Mesopotamia civilization, which was around 3500 BC to 5000 BC, was naturally a revolution in the transport system. Moving on a single wheel was not so easy, and therefore man soon learned the art of joining two wheels to get the advantage of an axle, and thereby built two-wheeled and four-wheeled carts and chariots. The art of road building soon began with the need to provide a hard, durable surface to withstand the abrading effects of these wheels. And if you look at the early history of roads around the world, it starts with the Roman roads, then the French roads, Metcalf Road, Telford Road, and Macadam's Road. I'll just devote few seconds on each of these. The Roman roads were constructed in 8th century BC, and Romans are considered as pioneer in road construction. The Roman civilization was well known for good road system it built, and about 100,000 kilometer road network served military and administrative purposes of the Roman Empire extended over vast regions. Rome was the focal point from where 29 major roads radiated in all directions. And probably this is the reason why it is called all roads lead to Rome. Because there were 29 major roads radiating from Rome in all directions. In the Roman system, it was a layered system, but very thick, 100 to 150 centimeter. The foundation soil was compacted properly, and above that there was a layer of bitumen. This is a layer of crushed rock which is around 25 to 60 centimeter thick. And above that it was rudus, a 20 centimeter thick layer consisting of crushed rock 5 centimeter in diameter in cement mortar. And above that there was a layer of nucleus. Nucleus was a concrete based layer made of cement, sand and gravel, and this was also around 30 centimeter thick. And finally it was cemum dorsum, the final layer consisting of large 15 centimeter thick rock blocks. That was the Roman road in 18th century BC. After the fall of Roman Empire, their technique of road construction did not gain popularity in other countries, and particularly because of very heavy structure. And therefore, the Tresaguet developed several methods of road construction which were considered to be advantageous and meritorious above Roman roads. The main feature of the proposal was that the thickness of the construction needs to be only 30 centimeter. And side drains were also provided in all these roads. Metcalf during 1765 to 1792 was engaged in road construction in England during the period when Tresaguet was working in France. And Metcalf was responsible for construction of almost 290 kilometers of roads in northern England. And if you see here, this was the cross-section of the road which was suggested by Metcalf. Here, the top surface is given a slope of 1 in 45, and that is what we call today the camber. And this camber is more or less similar to what we are providing even our national highways or state highways today, that is 1:40 to 1:50, and here it is 1 in 45. The sub base was large foundation stone, and then above that it was broken stone of 8 centimeter thickness, and finally a sloping wearing surface at a slope of 1 in 45. Now Telford construction during 1757 to 1834 Thomas Telford was the founder of the Institution of Civil Engineers at London, and he began the road construction in the early 19th century. He used heavy foundation above the soil subgrade and provided cross slope on top surface by varying the thickness of foundation stones. The important consideration here was that cross drains were also provided at an interval of 90 meter. Now, during this period, there were different stages of road development, but among all these, Macadam Road was the most successful. John Macadam, who was a Surveyor General of Roads in England, suggested an entirely new method of road construction on scientific basis. He realized that the stresses due to wheel load gets decreased at the lower layers, and so it is not required to provide thick pavement layers. The importance of subgrade drainage and compaction was recognized, and therefore subgrade was compacted and was prepared with a cross slope. Now here cross slope was started right from the subgrade level. So it's a compacted subgrade, and above that you have broken stones passing 5 centimeter sieve, thickness 10 centimeter, and above that you have broken stone and the surface course with stone. Now the total thickness is only 25 centimeter. If you look at early civilization in India, the Mauryan emperors built very good roads during 321 to 185 BC. And Chandragupta Maurya constructed around 2,400 kilometers of the roads across the subcontinent, connecting Patliputra to Takshila. Kautilya, the great administrator of that time, laid down the standard width of various classes of roads. And a Greek ambassador, Megasthenes, wrote that Mauryan rulers were great road builders. Special care was taken to repair the roads. Trees were planted along the roads to give shades. Wells were dug and rest houses were provided for the comfort of the travelers. Then after Mauryan Empire, Gupta period was there from 270 AD to 467 AD, and that was the golden era of Indian history. Roads received a great impetus. A Chinese visitor, Fan, who visited India in 405 AD, traveled widely on Indian roads and has left impressive accounts of the road system. He was particularly impressed by the security and comforts provided to the travelers. Now, history of roads in India will not be complete if great work of Sher Shah Suri is not mentioned. Sher Shah Suri, the Pashtun monarch during 16th century, built Grand Trunk Road, GT Road. The road was originally built from Agra, the capital city of Sher Shah Suri, to Sasaram, that was his hometown, and he named this road as Sadak-e-Azam, where he introduced coarse minars, which are equivalent to our modern milestones. One course was 3000 meter, that is 1.8 miles. After Sher Shah Suri, the Mughal emperors extended this road westward to Kabul and eastward to the port city of Chatgaon. The period covering decline of Mughals and the beginning of the British rule was a period of neglect of road systems in India. Lord Dalhousie organized to form a provincial PWD in place of military board in 1885 for maintenance and construction of roads. Specifications were framed for construction of road in India. As a result, good system of trunk roads in the country was there by the end of the 19th century. A real setback to road system came after introduction of railways in 1853. The Grand Trunk Road from Calcutta through Delhi to Peshawar was rebuilt at a cost of €1,000 per mile. Roads from Bombay to Pune, Bombay to Agra, Bombay to Madras were also constructed during the period 1833 to 1866. And that was the time when Public Works Department and Thomason College of Civil Engineering, Roorkee were founded to train and employ local surveyors, engineers and overseers to perform the work and to maintain the roads. And this program resulted in an estimated 2,500 kilometers of metal roads being constructed by the end of 1850s. And I told you railway was introduced in 1853. The need of administration and military was adequately served by railways. Primitive roads transport means were limited to horse carts and bullock carts only, whereas railway was a quicker means of transport. And therefore, the time between 1853, that is the advent of railway, and 1897, when the first car came on the Indian roads, was the darkest period in the history of road in India. After First World War, there was a rapid growth in motor transport. The pneumatic tired vehicles caused rapid deterioration of Indian roads, which were already in very sad state of neglect due to lack of government interest and inadequate finance at the command of the local bodies. Voice for better roads was raised in the Council of States. Government of India appointed a committee which is called Mr. M.R. Jayakar Committee in 1927. The mandate of this committee was to see the desirability of road network, finance role of states and central government. Committee said that development of road system is beyond the financial capacity of local government and therefore should be charged on central revenue and taxation system. And as a part of recommendation of this committee, Central Road Fund was set up in 1929. Then subsequent development was formation of Indian Roads Congress in 1934 to frame the guidelines and standards for road construction in India. Nagpur Road Plan was drawn for 1941 to 1961, and the basic target of this plan was to have a road length of 16 km per 100 km square area of the country. This Nagpur Road Plan provided certain rational formulas to determine the length of roads of different categories. Central Road Research Institute CRRI was set up in 1952 for fundamental and applied research in roads. National Highway Act was passed in 1956. National Highways Authority of India was set up in 1988 for development of highways in the country. And second 20-year road plan, which is also called Bombay Plan, was made in 1961 to 81. And third 20-year road plan, that is Lucknow Plan, was for the period 81 to 2001. As I told you, this Nagpur Road Plan fixed a target of 16 km per 100 km square area of the country. The second 20-year road development plan, that is also called Bombay Plan, set the target of 10,57,330 km road network in the country, with National Highway, State Highway, MDR, ODR and village roads. And provision of good communication in the rural area is essential to check increasing urbanization. Strategic needs in economic, industrial and agricultural sites are to be duly taken care of. And targets of every category of roads were set based on some rational formula. During 1981 to 2001, that was Lucknow Plan, third road development plan, where targets were enhanced for National Highway, State Highway, major district road, other district road plus village roads, with a total target of 27 lakh of kilometer of road network in the country. National Highways Authority of India was constituted by an Act of Parliament in 1988, but this authority became operational only in February 1995. Since then, NHAI has implemented several projects of national importance, and the length of national highways in the country has increased tremendously over last 3 decades. In 1950, there was only 19,811 national highways, and in 2020, this length increased to 132,500 kilometers. The financing of roads in the country, as I told you, as a recommendation of Jayakar Committee, Central Road Fund Act 1929 was enacted by levying petrol 2.64 paisa per litre, and 20% of this money was retained by center for research and experimental work, and 80% of this money was given to states in the ratio of petrol consumption. Now it is now rupees 18 per litre as Road and Infrastructure says. CRF Act 2000, which has been further amended in 2017, and it is now Central Road and Infrastructure Fund Act. The distribution of high-speed diesel oil and petrol cess is like this, that 39% of this is retained by central government for development and maintenance of national highways, and 2.5% for development and maintenance of waterways, and remaining for the development of state roads and rural roads in the country. Banks have been the conventional loan providers for road projects in India. However, in the past few years, several long-term investors have emerged in the market, and their preferred route of investment are toll, operate, transfer bundles, where investor gets the right to collect tolls from the road project for a long duration to recover the money. Now NHAI has begun the asset monetization on two tracks, one through this TOT, that is toll, operate and transfer system, and the other through infrastructure investment trust, that is called INVITE. NHAI plans to raise around rupees 1 trillion by monetization of highways under TOT model. At least 12 lots of highway bundles of over 6,000 kilometers will be monetized before 2024. And it also expects to raise about 51 billion Indian rupees by launch of INVITES, which has now been approved by SEBI, that is Security and Exchange Board of India. The scale of road construction in India has increased, and in November 2020, the total road length in the country was 5.897 million kilometers. The road connectivity in rural area is almost 91%. National highway network, as I told you, it stands at 132,500 kilometers in 2020, and speed of construction of national highways in the country was 27 kilometers per day in 17-18, which is now around 30 kilometers per day. In rural area, during 2017-18, the NRDA constructed around 134 kilometers of the road per day. Now coming to advanced technologies in road construction, there are several technologies which are being used nowadays in modern road construction. Plastic waste in bituminous layers, warm mix technology, cold mix technology, where you can make a road at ambient temperature without heating binder or aggregate, recycling of pavements, geogrid and geotextile in pavement construction, new generation additives for soil stabilization, waste materials and porous asphalt. And almost each of these technologies now has become a mainstream technology. Majority of them are being used in India and in many other countries. And many of these technologies have been discussed in different sessions in my YouTube channel also. But there are certain futuristic technologies which should be discussed here. One is self-healing pavements, then precast roads, solar roads and plastic roads, fully plastic roads. The self-healing pavement is a self-healing technology for flexible pavements where bituminous materials enable a system to self-heal after initiation of cracks. When the bituminous material is subjected to a rest period, it has the potential to restore its stiffness and strength by closing the micro cracks that occur when pavement is subjected to traffic loads, and this is called self-healing. There are several materials which are used as self-healing materials in bituminous construction, use of nanoparticles like nanoclay or nanorubbers, or it can be rejuvenators like microcapsules, binder healing agents, or byproduct of waste cooking oil. It can also be achieved through induction heating of bitumen containing conductive fibers and fillers. Microcapsules are embedded throughout the bituminous mix, and whenever there is a crack, the top surface of the pavement is heated through induction, and these fibers or these capsules melt and they heal the crack. Precast concrete roads. This is a serious need of the country today. Rapid and long-lasting construction and repair and rehabilitation of concrete pavements under heavy urban roads or in far-flung areas of the country. In a conventional method, when traffic is opened after 7 days of curing, the concrete does not gain its full strength, and therefore it results in shorter service life. Closure of the road for a long time to get the full strength of the concrete many times is not feasible or not practical. Therefore, need is to have precast concrete slabs that can be casted in yards and transported to the site and fitted on the road. The solar roads. The main purpose of solar roads is to replace asphalt roads with solar panels which can generate energy through the sun. And these panels will also increase the number of charging stations for electric cars if that station is connected to solar roadway. And this is the Wattway Solar Road, which is an experimental stretch in France. Another one is plastic panel roads. This concept consists of a prefabricated, modular and hollow road structure based on recycled plastic. The plastic roads are made entirely of plastic or of composite of plastic with other materials. These hollow plastic road element can accommodate all kinds of cables and pipes, and in case of extreme heavy rainfall, it can also be used for storm water retention. An experimental bicycle track of 30-meter length has been made from recycled plastic in Netherlands as a part of the project that could lead to more sustainable roads. And another one is smart roads. Smart highways, that is the future of transport, and it involves using sensors and IoT technology to make driving safer and greener. They give drivers real-time information regarding traffic information, congestion and parking availability, for example, and also weather conditions. The idea here is that each vehicle should communicate with all other features of the road. There should be a communication between vehicle to vehicle, communication between vehicle and roadside unit, communication between vehicle and the pedestrian, communication between vehicle and the mobile network, and also to GPS. And that is the ultimate aim of intelligent transport system, that there should be no fatality, no crash, no collision between vehicles and between vehicle and pedestrian. Another one is anti-icing roads. Traditionally, de-icing methods to protect road surface against slippery conditions are to distribute salt and sand on the road. Now the emphasis is on anti-icing rather than de-icing. Now de-icing is to melt the ice on the road surface, while anti-icing is an action to prevent ice formation on the road surface. Now anti-icing additives are being developed to prevent the problem of snow on road surface. And these are now coming up in market. So friends, I will close this discussion here with the very well-known statement of J.F. Kennedy, the President of USA, that it is not our wealth that built our roads, but it is our roads that built our wealth. Thank you very much for watching. You can write your suggestion and comments.